needs to grade it. Go to question 3. Now we actually run the ANOVA. So here would go your descriptives, here goes your graph. Next, here's our null and alternative. Notice that it's always written out in words. There's no relationship between the two variables. In other words, all population means are equal, and at least one population mean is different, so not all equal. So now we do the assumption check. Well, here's the decision tree and a link to how to view the decision tree, how to use it. The major assumptions for one-way ANOVA are all individuals are always independent. We always assume that. For each group, either the outcome variable is normally distributed or n is large, at least 30 for each group. So click OK. We don't talk about n or p because it doesn't make. Don't talk about p. That doesn't make any sense. It's not a categorical variable. We do not need the outcome and input to be normally distributed. The outcome doesn't need to be normally distributed if n is large. We actually kind of do assume there are no extreme influential points, but I didn't put that in the assumption check because that's actually part of what it means to be normal. Anyway, the point is the variance similarity is the only other assumption. So these are the 3 assumptions for one-way ANOVA as I put it in the decision tree. Among all the groups of major simple, what's the smallest sample size? Well, let's go look. Smallest sample size is 3. Now make a histogram. So I'm going to go make a histogram, ignoring group membership. So, or a box plot would be fine. I'm going to make a histogram. Graphs and tables, histogram, exercise, OK. And there it is. That is skewed right. And I would get the same thing if I did a box plot. Graphs and tables, box plot, exercise not separated by anything, and then click OK. And that's very skewed right. So that's highly skewed to the right. The positive end is dragged way out to the right side. So highly skewed right. Are there outliers? Yes! It's quite a lot of outliers. So sample size is small, and it's definitely not normal because there are outliers and skew. So do we meet the assumptions for normality and or sufficient sample size? No, we don't meet that assumption. Next, we want to check the homogeneity of variance assumption. So what is the ratio of the largest standard deviation divided by the smallest? So I'll go back to my descriptive statistics. The largest standard deviation is 198.19. So I'm going to copy that. Open up, say, Excel to do my computations. Paste that. The smallest standard deviation is 3.86. Copy that. Paste that. And equals the largest divided by the smallest. And I get 51.28. Which is what I'll put. 51.28. Do I meet the assumption of homogeneity variance? Well, if that ratio is less than 1.75, then we meet the assumption. If it's bigger than 1.75, we don't. That's just a rough rule of thumb that I give you right here in this question. So it's right there. It says no. Right? 51 is bigger than 1.75. So do I meet all the assumptions? No, I don't. And I actually don't think I meet any of the assumptions. But we're going to move on anyway because it's a class project. So submit. Double check that I got all green boxes. And that's fine. Now I'm going to move on to the actual ANOVA part. So I need my degrees of freedom for treatment and for error, the F, and the p-value and the decision. So let's go. This is actually pretty much the easy part. So I'm going to scroll. If I run the ANOVA, I haven't run the ANOVA. So statistical analysis, continuous variables, one-way ANOVA. And it says in the instructions to use the Tukey pairwise comparison option. So I'll do that, Tukey. And then I'm going to choose response variable as exercise, and major simple is the grouping variable. And then I click OK. And it spits out graphs that I find useful, like here I've got confidence intervals, and here I've got a bar graph. We don't need them anymore, but we can use them to interpret what we're doing. So it gives me the last stuff first, so I'm going to scroll up to get to the ANOVA table. ANOVA summary table is what I need to find right now. And there it is. So there's my F is 4.107. That's my test statistic. My p-value is 0.00649. I'm going to copy that. Paste that. Now, the degrees of freedom. Well, there are 1, 2, 3, 4, 5 different major groups, and so that means that there are 4 degrees of freedom for between groups comparisons. I can also find that in my R output. It's right here where it says degrees of freedom for the factor is 4. Degrees of freedom for the residual, that is between groups, within groups rather, is 44. Okay? And then so anyway, my decision, that p-value is smaller than alpha, so I reject HO. HO said there's no relationship because all means are equal. It means I conclude the means are not all equal, and therefore there is a relationship between major, simple, and exercise. And again, all the responses are correct, but it's giving me a yellow. That's for reasons that are beyond, they're not relevant. So click the last question. Almost done here. What do I conclude? Well, here's my p-value. This is what I typed. I'm not saying it's correct, although I got green checkboxes. I know it is correct. What's my decision? I reject HO. That's what I decided. So what do I conclude in plain English? Well, it means there is a relationship. I rejected HO. It means there is a relationship. If I reject HO, now I need to find out why. And this is where we look at the Tukey post-hoc comparisons. So I'm going to go look at the p-values. I've reproduced them here for you, but I need to look at the direction of the p-values as well. So, looking down at the last part of the output, this is the Tukey pairwise t-tests. These are 2 sample t-tests that have been adjusted to make them more conservative. So I'm going to first look at the mean of general minus the mean of business. The difference is positive, but the p-value is large, so I don't reject HO, and I conclude there's no difference. The second one has no difference. The third one is different. That p-value of 0.002 is smaller than 0.05. I reject the null and conclude that IT is different from business. The mean of IT minus the mean of business is 131.8. That's big, positive number. So that means that IT is bigger than business. So, for this p-value, no difference. No difference. For this p-value, there is a difference, and specifically, the IT mean is larger than the business mean. Here again, no difference. No difference. Any p-value that's larger than 0.5, we conclude that there's no difference, or 0.05. Any p-value that's smaller than 0.05, we conclude there is a difference, because I said we're going to use alpha of 0.05. You compare it to whatever your alpha is. This p-value is small. IT minus general other is different. Let's look at it. The mean of IT minus the mean of general other has a positive value, 129.7. That means that IT is bigger than general and other. This p-value is larger than alpha, so there's no difference between social and general other. This p-value is small, so we'll go compare IT to health and life. IT minus health and life is positive number, 127, so that means IT is bigger than health and life. And the others are both no difference, because these p-values are larger than alpha. And so what's this tell me? What it tells me is that people in the IT group are exercising, on average, more than everyone except for the social science group. Furthermore, there are no other differences. So that's, I did an analysis, I rejected HO and concluded that in the population, some major is exercising more or less than other majors. At least one pair is different. Then I ran a pairwise comparison and discovered that the reason is the IT people are exercising more on average. Why is that? It's just because of error. It's a type 1 error. It's not a real finding. I didn't meet the assumptions for the test. The test is completely invalid. But I want you to get practice with it, and that's the idea. Alright, so I'll make another video showing you how to do the other 2 ANOVAs next.